Welcome back. Today we will be looking at the topic laws of indices, and this is part 2. Remember, laws of indices enables expressions involving powers to be manipulated more efficiently. An index, which is the singular term for indices, is the small floating number that appears after a number or letter. Here's an example. The small floating number that we have here is this 2. The 2 is what we make reference to as the index, exponent, or power. It is the small floating number that we have above this 3. The 3 is what we call the base. In this video, we will be looking at laws number 4, 5, and 6. Starting with law number 4. Law number 4 is the negative power law. This states that a negative power can be rewritten as a fraction. In the general example that we have here, we have negative m being the power, and on the right hand side of the equation, we can see that it is rewritten as a fraction of 1 divided by x to the positive m power. Now we realize that in this example, the negative m over here was changed to a positive m over here when it is written in the fractional form. Let us look at a more detailed example of the negative power law. The first example, we have x cubed divided by x risen to the 5th power, or it can be rewritten in this form also. They are both the same questions. Now we know the division law states that whenever we're dividing bases of the same, we subtract the power. Now our powers are 3 and 5. When the bases are the same, we rewrite the base. That is what we did. We rewrite the base of x down here, and we subtract the power. We're subtracting 5 from 3. The difference here, in previous examples, we were subtracting the smaller number from the larger number, which gave us a positive. However, in this example, we're subtracting the larger number, which is 5, from the smaller number, and we know that when we subtract a larger number from a smaller number, it's going to give us a negative. Hence, we end up with the answer x to the negative 2 power. Now this is where the law comes in effect. Let us look at the expanded form for the same example. Same question, x cubed divided by x to the 5th power. We have it here, x cubed divided by x to the 5th power. Now if we do this in the expanded form, we know that the base tell us what to multiply, so it's telling us that it's x we're going to multiply, and the power tells us how many times we're to multiply it. So this 3 is telling us that we need to multiply x by itself 3 times. Likewise, this x risen to the 5th power is saying we're going to multiply x by itself 5 times. Now this is what we have here written in the expanded form. X in the numerator being multiplied by itself 3 times, and x in the numerator being multiplied by itself 5 times. Now, in normal division, when we have it written in the expanded form, we know that we must cancel out whatever we have in our denominator with whatever is in our numerator. Since we can cancel x into x, which goes 1 time, then this x will go into this x 1 time, and this x cancels this x 1 time. Now we don't have any more x to cancel in our numerator, so we're finished canceling. We now need to rewrite what we have remaining. In the numerator, we do not have anything remaining but 1, because remember, everything up there is cancelled once, so therefore 1 times 1 times 1 is just 1, and that is what we have rewritten down here in the numerator. For the denominator, we realize that not all the x's were cancelled. There is still 2x remaining. In order to rewrite this in exponential form, we have to place a base and a power, or an index. Now, how can we determine what our base is, and how are we going to determine what our power is? Remember, whatever is being multiplied by itself is going to be our base. So since x is being multiplied by itself, that is going to be our base. So our base here is still x. How we are going to determine what our power is by counting how many x's there are. How many x's being multiplied by itself will determine our index or our power. We have 2x being multiplied by itself here, and this is our new power 2. Now it was the same question we have here, same question over here. Here we have x being risen to the negative 2 power. Here we have 1 divided by x to the positive 2 power. Same questions, therefore the results must be the same. This is here to show you that this x to the negative 2 power is the same thing as 1 divided by x to the positive 2 power. So in any event that you see a base risen to a negative power, you can rewrite it as 1 divided by that same base and a positive power. Now we're going to look at law number 5, and this is the power of 0 law. The power of 0 law simply states that anything risen to the power of 0 is equal to 1. So we have two examples here. X risen to the power of 0 is equal to 1, and 5 risen to the power of 0 is also equal to 1. Now it doesn't matter if it's a numeral or a variable that is risen to the power of 0, they are both equal to 1. Here's an example or proof as to why this is so. The question that we're given is x risen to the 4th power divided by x risen to the 4th power. Now, we know that x risen to the 4th power just means that we're multiplying x by itself 4 times. That is what we have written here in the expanded form. Same thing for the denominator, x risen to the 4th power is x being multiplied by itself 4 times. Good. Now we're going to divide now. By dividing in the expanded form, we're just going to cancel out. So x into this x gives us a cancelling of 1. Then x into x goes 1 time, x into x goes 1 time, and then x into x goes 1 time. So if the only thing that we have after cancelling is just 1, 1 multiplied by 1 multiplied by 1 multiplied by 1 is just 1. Looking at the alternative method, same question. Now, we know that when we have bases of the same and we're dividing, we subtract the power, right? So, if the base is x, we rewrite that x and we subtract the power. Now, both our powers are 4. So, 4 and we subtract 4 from it, we're going to end up with a 0. So, x risen to the power of 0, right? Now, we know that x risen to the power of 0 is just 1. This is where the law comes in place. Again, anything risen to the power of 0 is equal to 1. That's what we have here. Same question, same answers. The final law that we'll be looking at is law number 6, the fractional power law. Now this states that the denominator of the fraction stands for the type of root. For example, we have this fractional power and the denominator is 3. So we know that the type of root is going to be a cube root because 3 represents cube. It further states that the numerator of the fractional power gives the usual power of the whole term. So therefore, the whole term is going to be risen by the numerator, which is 1. In this case, the 1 was not placed here simply because 1 changes the value of nothing. I'm going to give you a further example. Now we have an example here, right? So we have x being risen to the power of m divided by n. So the fractional power is m divided by n. If we should rewrite this, it is rewritten in this form. Remember, we place the base on the inside of the square root symbol. We place the numerator of the fractional power outside of the bracket, so everything is risen by the numerator of the fractional power, and the denominator of the fractional power determines the type of root, and it goes right here. Let's give you something with some numbers now. Alright, so to take a look at the second example that has numerical values, we have 4 risen to the 2/4 power. Now, if we should rewrite this, we're going to have this being our result. simply because the base is what goes inside the symbol, the numerator is what everything is risen by, and the denominator tells us the type of root that we're dealing with. So we're dealing with the fourth root, and after working it down, we know that we are going to end up with 16 inside our square root symbol. In this case, our fourth root symbol, because the 4 there represents that it's a fourth root instead. We end up with 16 because 4 risen to the power of 2 is 16. 4 times 4, 16. We know that it is a fourth root, and we put it back there. Since we're finding the fourth root, we know that we're finding the fourth root of now 16. And the fourth root of 16 is just 2. So after you have the question in this format, it has to be rewritten, and then we break it down by doing the following procedures. Thank you for watching. I hope you learned something, and I'll see you in the next video.